D. Docs present Wonder Number 33, The Architecture of the Hive. How a tiny six-legged architect built a masterpiece of nature and showed humanity how to build a society. Imagine standing in the middle of a sunlit meadow on a warm afternoon. The air is thick with the sweet scent of clover and wild thyme. All around you, the world is humming. It is a low, steady, hypnotic sound like a tiny engine running just beneath the surface of the earth. If you crouch down low in the grass and look closely at a single yellow blossom, you will see the wonder. She is small, fuzzy, and dusted from head to toe with bright yellow pollen. She lands on the petal with all the grace of a falling feather. She does not rush, she moves with total purposeful focus. She dips her head, drinks her fill, and gathers her cargo. Then, with a sudden sharp buzz, she launches herself back into the sky, carving an invisible highway straight through the open air. We hear the sound of a million times in our lives. We wave our hands lazily to brush a bee away from a glass of lemonade at a summer picnic. We duck our heads when one buzzes a little too close to our ears in the garden. We treat them like noisy little background characters in the grand story of nature. But here is the big question. What is really happening inside that hidden world? How does an insect smaller than your thumbnail organize an entire city, build perfect geometric architecture, and keep life on Earth alive without a single blueprint, boss, or computer? To find the answer, we have to look past the stinger and past the honey jar. We have to look inside the hive. To understand bees, you have to throw away everything you know about how individual animals live. If you look at a single honeybee crawling across your porch, you are not looking at a complete animal. You are looking at a single cell of a much larger creature. Scientists call this a superorganism. Inside a healthy hive, tens of thousands of individual bees live, work, and die together for one singular goal: the survival of the collective family. A healthy hive may contain 50,000 workers, yet no bee is in charge. There is no foreman, no architect, no written schedule. Order emerges from thousands of tiny decisions made every minute. No single bee can survive on its own for more than a day or two. If you pull one bee away from the colony and leave it out in the open world, it will quickly panic, lose its way, and perish. Its life only has meaning inside the absolute unity of the hive. Every bee has a strict, carefully timed job description that changes as she grows older. When a young worker first emerges from her wax cell as an adult, her very first job is not flying out to the flowers. Her job is cleaning. She spends her first days polishing the nursery cells until they shine like porcelain, making sure the environment is spotless for the next generation. As she grows older, her body changes and her duties shift. She becomes a nurse bee, feeding the hungry larvae with royal jelly and pollen, running back and forth across the honeycomb like a tireless babysitter. Next, she graduates to construction. Her body secretes pure liquid wax from glands on her abdomen, which harden into delicate scales that she scrapes off with her legs, chewing it up to build the iconic hexagonal wall of the hive. Later still, she becomes a guard at the front entrance, inspecting every incoming visitor to make sure no foreign invader or robber bee tries to sneak past the threshold. Only at the very end of her short life does she become a field forager, flying out into the dangerous, unpredictable world to gather nectar and pollen until her wings literally fray and wear out. She does not complain. She does not ask for a promotion or a vacation. She simply executes her role with absolute, selfless precision. If you slice open a honeybee nest, you will find one of the most stunning sights in the natural world, the honeycomb. It is a vast golden sheet of identical six-sided cell fitted together so tightly that not a single microscopic scrape of space is wasted. For thousands of years, humans have looked at the honeycomb and wondered at its perfection. Why a hexagon? Why not a circle, a triangle, or a square? Circles leave awkward, empty gaps between them, wasting precious space and leaving structural holes. Squares and triangles can fit together without gaps, but they require uneven amounts of material and create weak stress points at their sharp corners. The hexagon is the ultimate mathematical compromise. It uses the absolute minimum amount of wax to enclose the maximum possible amount of space. It is sturdy, it is lightweight, it is an engineering masterpiece. Engineers have borrowed the honeycomb pattern for everything from aircraft panels to spacecrafts because nature solved the problem of strength and efficiency long before humans ever picked up a blueprint. Now, for a time, long before human mathematics argued over whether bees actually understood geometry or if they were just following a blind, simple biological reflex, the truth is even more fascinating. Bees do not sit down with a tiny ruler and compass and draw out their blueprints. Instead, they build their cells out of warm, malleable wax, using their own bodies as living compasses. As hundreds of bees crowd together in the dark hive to build the comb, the heat of their bodies soften the wax. And as they press against one another, the natural physics of the crowding forces the soft wax to flatten and to pull into natural six-sided shapes, just like soap bubbles pressing together in a sink. Nature and math working together in the dark. That's pretty much what it boils down to. Now, how do bees communicate? They cannot talk to one another with spoken words. They do not leave written notes. Yet, when a scout bee discovers a rich, untapped field of flowers blooming 3 miles away across the valley, she needs a way to tell her sisters exactly where to find it. She does this through an astonishing performance known as the waggle dance. Yeah, truly. Imagine trying to give someone GPS directions using nothing but dance moves performed in complete darkness. That's exactly what a scout bee does. When the scout returns to the dark interior of the hive, she climbs onto the vertical face of the honeycomb and begins to move. She runs in a tight figure eight pattern. She crosses the center line of the figure eight. She shakes her abdomen rapidly from side to side, creating a distinct buzzing vibration with her wings. The other bees crowd around her in the dark, pressing their antennas against her body to feel every twitch and note. Every part of the dance carries precise instructions. The direction of the waggle run tells the other bees the angle of the food source relative to the position of the sun. The duration and speed of the waggle tell them the exact distance they need to fly. The enthusiasm of the shake tells them how rich and abundant the nectar is. It is a complex symbolic language performed entirely in pitch darkness, translated instantly into flight paths across the open landscape. Now, beyond their own tiny world, bees hold an extraordinary responsibility that reaches far, far, far beyond the hive. They are the great matchmakers of the plant kingdom. Hear me out. As a bee crawls deep inside a flower to drink nectar, her fuzzy body brushes against the plant's pollen producing parts. The golden dust clings to her tiny hairs. When she flies away, the next flower of the same species, some of that pollen rubs off on the new plant. This process is called pollination. Without it, most flowering plants could not fertilize, grow seeds, or produce fruits. Entire ecosystems depend on pollinators. When bees thrive, birds, mammals, insects, and forests all benefit. Think about the food you eat every single day. Apples, pears, and peaches, strawberries, blueberries, and raspberries, watermelons, cantaloupes, cucumbers, almonds, broccoli, and tomatoes. Around 1/3 of global crop production benefits from animal pollinators, with bees doing much of the work. If bees suddenly vanished from the earth, our grocery store shelves would look heartbreakingly empty. The colorful variety of our diet would shrink down to plain wind pollinated grains like corn, wheat, and rice. The world would lose its color, the sweetness, and its vibrant life. Now, despite their importance, modern bees are facing severe multi-front crisis. For the last several decades, beekeepers and scientists have watched an alarming number of colonies weaken, collapse, and die off. What is hurting the bees? Loss of habitats. As human cities, sprawling suburbs, and massive concrete parking lots expand outward, wild meadows and wildflower fields are paved over, destroying the natural foraging grounds bees rely on for food. Agricultural chemicals. Modern farming often relies on powerful chemicals and pesticides sprayed onto crops to keep pests away. Some of these chemicals can disorient bees, disrupt their memory, or kill them outright. Parasites and diseases. Tiny destructive invaders like varroa mites, a microscopic vampire-like tick, attaches themselves to bees, draining their life fluids and spreading deadly viruses throughout the colony. When a hive is hit by these combined pressures, it can fall victim to colony collapse disorder, a mysterious phenomenon where the adult worker bees suddenly vanish, leaving behind a bewildered queen and a starving brood with plenty of honey, but no one left to tend to it. Or tend it, I should say. Now, the story of bees is not just a tragic warning about a fragile ecosystem, it's a call to action. Across the entire world, people are finding simple, practical ways to protect our six-legged neighbors. Planting window boxes, rooftop gardens, and backyard flower beds with native pesticide-free wildflowers that bloom all season long, leaving patches of wild lawn untouched so clover and dandelions can provide vital early spring food sources, supporting local independent beekeepers who practice gentle, sustainable hive management instead of rushing to maximize commercial honey output at the expense of bee health. You don't need to be a professional scientist or own a sprawling farm to make a difference. Even a single pot of lavender on a sunny balcony can act as a safe refueling station for a tired forager. So if you can, just do your part to help the bees and help the planet. Let us return to the quiet meadows where our story began. The sun is sinking lower in the western sky. The golden light catches the gossamer wings of a worker bee as she makes her final journey back toward the hive, laden down with the sweet rewards of the day. When we look at a bee, we are looking at something much larger than an insect. We are looking at a living masterclass in cooperation, patience, and tireless dedication. A single bee cannot change the world on her own. She is too small. Her life is too short and her strength is too limited. But when thousands of them work together in absolute harmony, they build empires of wax, sweeten the earth, and keep the cycle of life spinning forward. The hive teaches us a quiet, enduring truth. No contribution is too small when everyone pulls together. Tomorrow morning, before the sun has fully warmed the flowers, the hum will begin again, and somewhere inside the hive, another generation is already preparing to continue a story that has been unfolding for millions of years. Headlines fade, culture lasts, and there is always more to the story.